Welcome to today's GATE video. I am C.BALAKRISHNAN, Associate Professor from C.H.E. Department of S.A.E. Engineering College. Today we have to see about the another subject, Programming in C Data Structures. So that first year I am going to teach about the topic pointers. So pointers is a variable that stores the address of a memory location. So pointers play an important part in the data structures. So the key to comprehending pointers is understanding how memory is managed in a C program. Okay, always. A pointer is a variable that contains an address in memory. So that pointer and memory have equal connection. So that in a 64-bit architecture, the size of a pointer is 8 bytes, independent on the type of the pointer. So several definitions are there. I am mentioning 2 or 3 definitions for that. Pointers are variables that store the memory address of another variable or data location, acting as a direct low-level bridge to the computer memory. So that's a bridge for the memory and the system. Okay. So they enable efficient access and manipulation of data stored in memory, including dynamic allocation and parsing large structures functions. So definition, the main important definition, if we tell that is particularly a pointer is a variable holding a memory address. So example, the address source rather than the actual data itself. So that must keep it in mind that is not the actual data itself. It shows some memory address. It shows the memory address. It represents some memory address. Memory access pointers are used to read and write to specific memory locations using the dereference operators, particularly in C++. Dynamic allocation. What is dynamic allocation? They are essential for managing memory in the heap, whatever the heap, allowing programs to request memory at runtime using functions like malloc or new, whatever the new function is there. Efficiency. What is the efficiency of the pointer? Are highly efficient accessing large arrays or structures because they pass the memory address rather than the copying the entire data. So always it directs data. It gives the user the memory address, copying the entire data structure instead of copying. Structures can point to memory address in different regions, particularly stack or the heap. Stack is that for local variables, and the heap is for the dynamic memory. So common uses. What are the common uses of pointers? Are pass by address, modifying variables inside a function by passing their address. Linked data structures, forming linked list trees and graphs. These are the linked data structures. And then the sharing memory. It can be used for sharing memory, allowing multiple parts of a program to access the same data. Let us notice that it gives some rough idea about the pointer whenever some pictorial representations. Notice the pointer P contains the address of the variable C and not the value contained. Okay, you could create a pointer like this in the manner shown to the left to the image. So if you see that whenever it shows the where it is stored, that particular pointer shows the where it is stored, it is called as this thing. Okay. So ways to get a pointer value. What are the ways to get a pointer value? Assign a numerical value into a pointer. How we can get is character. What is the character P? Suppose the value is, we store a 5 in a location in the 1800. You can see how do you go about creating a pointer to a location and then assigning a value to the memory. So that we can get. So assigning a numerical value isn't recommended and only left to programmers always. Of the operating system, kernels or device drivers. Common problems with the pointers. We have seen what are the uses, advantages and all. What are the problems, so that we can be careful in handling the pointers. Common problem with the pointers: when using pointers, make sure the pointer is pointing to valid memory. Always you must check whether the memory is valid or not before assigning or getting any value from the location. That is very much important. Next, string functions do not allocate memory for you, characters or something, copy or whatever the uninitialized pointer like that. The only string function that allocates memory is start up. It calls the malloc of the memory alloc of the length of the string and copies it. Whatever the allocated memory for that that you can be used for that, it will be allocated. Next, we will go some of the questions and answers regarding the gate questions. Okay, so question 1, memory management errors. What are with the memory management errors? Question: which of the following statement about pointers in C are true? Pointers can be used to access array elements. Pointers can store the address of another pointer. Pointers are a fixed size regardless of the data type they point to. Example given of the same size. A pointer can be reassigned to point to another data item. So what will be the answer for this? Answer: all of the statement listed according to the features of the pointer. These all the statements are true. Pointers are fundamental to accessing the array element in C. A pointer to a pointer is valid concept in C. A pointer to a pointer is a valid concept declared using the hashtag. The size of a pointer is system dependent always. For example, 4 bytes on a 32-bit system, 8 bytes on a 64-bit system, like that. But consistent for all the data types of the system. Pointers are variable and can be assigned new address. So all the statements are true for the first question. Next, question 2, dynamic memory allocation and memory leaks. What is that? So suppose I have showing you a program, include stdlib.h, include stdio.h, so that from that here the size of the integer is given in the allocation, memory allocation, and then the values are declared 10, 20, like that, the size of the given. Does this program can have any issues related to memory management? So you know that it leads to the pointer leads to the memory management. So any problem is there, or memory leaks means whatever the memory is not used or something like that. What happens here? Answer: yes, the program has a memory leak. Memory is allocated first in the initial using malloc, and the address is stored in X. Okay, then X is assigned the address of a second malloc allocation, overwriting the reference to the first memory block. So what happens? The first block of memory containing the value 10 can no longer be accessed or fed by the program, leading to a memory leak. So that whatever the thing is, other part of the thing will be wasted. To avoid the leak, the first allocated memory should have been freed before reassigning the pointer. So that is the main thing we have to take care. To avoid the leak, the first allocated memory should have been freed before assigning the pointer. Question number 3, pointer arithmetic and subtraction. Question. What is the question is? Consider two pointers P and Q of the same type. What does Q minus P return if they point the two elements in the same array? This is the main thing that you have to take care of. That same array, if you are doing, what happens? So here answer, it returns the number of the elements between the two pointers. Okay, not the number of bytes. So formula that the address of Q minus address of P divided by the size, what are the type that. So example, if P points to A and Q points to A1, A0 and Q points to A1, then Q minus P equals. So that is one of the important thing you have to notice here. Next one. Question number 4. what is recursive pointers and strings. What is the output of the following program? Void AB characters, and if S is 0, that it returns some value. What is the ABC S plus 1, ABC S plus 1, next printf. So what are the things we have to take care is, let us see what is the recursive pointers. Recursively we are giving the pointer value. Clear? So that's what happens here. So answer 3, 3, 2, 3, 3, 2, 1. For a string of length n, the total number of character printer is 2 to the power n minus 1. So for n is equal to 3, here 3 we are giving, isn't it? So 1, 2, 3, it prints 7 characters here. So that's what 3, 3, 2, 3, 3, 2, 1 we are getting. Question number 5, pointer dereferring and Indianness. What is called is, find the output of the following code, that the void main integer I 320 we are giving the value. So pointer, the character gives the pointer value and then it gives what is the value we are getting. Let us see the answer for this. Answer 64. Little Indian machine. So you know that Little Indian, Big Indian machine value is here. According to the Little Indian machine, what happens? Explanation: 320 is in binary. 16-bit is what is the value is. This is the value for the binary value of the 320. A character pointer points to only the first byte. On the Little Indian, the first byte is the least significant, which is 64 in decimal. Whatever the value we are getting, it is 64 in decimal. Next, question number 4, memory errors and matching. So it covers a different type of things we are used in the memory and the pointers. Scenario, some scenario, and we are giving the description here. The value of the m is equal to m alloc 5, m is equal to null. Here lost memory or memory leak. Next is comparing the matching. You have to see the matching for that. Free n implies the value is equal to 5. Dangling pointer. Character p is equal to a, uninitialized pointer. Let us see the what is the answer for the question. So these are the things, question answer for this one. Okay. So next one, function pointer declaration. Question: what does int declare? Here let us see the answer for this. A pointer to a function that takes an integer pointer as an argument and returns integer. So always, what is the tip given here is, always read from the innermost parenthesis outward, tells you it's a pointer and tells you the argument type always. So that is the thing whenever we are seeing the pointer to a function that takes an integer pointer as an argument and returns an integer. Next, question number 8. What does the following fragment of C program print? So 4 options are there. Character C gate 2011 was 2011. Character P is equal to C. Printf whatever the thing value. So here 4 options are there. Gate 2011 E 2011 011. So let us see what is the answer for this one. Step, understanding the string. First you have to understand the string for one. C is equal to gate 1. So what is the index we are giving is 0 1 2 3 4 5. Gate series. So P3 is whatever the thing is, value is E, and the 1 is A. Here we are getting. So convert the character to ASCII value that we are converting. E is 69 and A is 65, so that whenever we P3 minus P1 is equal to 65, the value is 4. Next, step number 3, evaluate the pointer expression. Whatever the pointer expressions we are getting, P is P plus P3 minus P1, P plus P3 minus P1, P plus 4 totally weird. So this becomes printf whatever the value is, whatever the value we are getting. So next step 4, what is at P plus 4? Next whatever the thing, index 4 onwards 2011. So the printed string is 2011. So final answer will be 2011. So this can be explained like this. Next, question number 9, size of pointer versus array. What is the size of the pointer versus array? So that integer array we are giving as 10. So whatever the pointer value we are getting to, it is directing to the array. What is the print value we are getting? Assume 4-byte integer and 8-byte pointer. Here what we are taking is the value, and then the options are 40, 40, 48, 840, 88. So let us see about that one. What is the answer for question number 9? What we are getting? Answer is 48. How it comes is, size of the array is equal to 10 into 4, so 40 bytes. Size of p is equal to pointer is equal to 8 bytes. So this will be the 8 bytes will be the pointer size here. Next, question number 10, double pointer. This is several, what are the pointers? Double pointer is one of the thing is used in the program. In the integer x is equal to 10, integer pointer is equal to what we are giving x. Like that it goes, the program goes. Options, address of x. It represents whether it represents the address of x or 10 or garbage. It goes to garbage or error. So that is the thing what we get when analyzing this explanation. Q dereference twice. So value of x, that's what we are getting the value 10 here. Next, 11, array and pointer confusion. Always will be having the array and pointer confusion will be there. Based on that, one problem is shown here. So integer array 10, 20, 30, 40 we are giving that, and next one is pointer value is C, A we are giving, printf. So whatever the value 20, 30, 40 and the error. These are some of the options given. How we can get here this, that let us see about the option. The answer is 30. How it comes is p plus 2 is equal to third element always. So here the 30 is coming. Next, question number 12, dynamic memory. You know that the dynamic memory is always used. So here what we are giving is integer p, integer memory allocation we are giving 5 into the size of the integer. What are the size of the integer? What will be the printf value we are getting? It will be whether it will be 0 or it will be garbage value or it will be error or it will be a 2. What answer is getting garbage value? Why we are getting is does not initialize memory. Always we have shown as M allocate. So M allocate, whatever the memory allocation does not initialize the memory. Here only for memory allocation is used for allocating the whatever the thing to the memory only. So here it won't be initializing the memory. So that's what that whatever the thing it goes to the garbage. No error. Next, question 13, memory leak. What happens to this integer p? The size of the integer we are giving that p is null we are giving. So here what happens to the memory? Several options have been given. Memory will be freed or memory will be leak or compiler error will be coming or runtime error will be coming. So let us see the answer for this memory leak, because originally what we are allocating in that is lost. So it will be leaking and you won't be getting any output for that. It's lost. No free here. So that's what that memory leak is the correct answer for this question. Next, question number 14, pointer to array. So pointer to array, whenever we speak about the integer a is equal to 5 number we are taking 1, 2, 3, 4, 5. P into 5, whatever the value it pointer shows here that a. Next 4 options has been given, 3, 4, address and error. What will be the value will be coming here? Let us see that. Explanation, answer is equal to b is equal to 4. Explanation, pointer to entire array, index what it will be index 3 will be showing 4. So that should be, so that's what it will be the value for this question. Question number 15, pointer increment. Another important part in the pointer increment how we are making. So integer array, integer a 1, 2, 3 we are giving, pointer value we are giving. Print what are the value have been given to take. Here 4 options have been 11, 12, 22 and 23 have been given. So let us see the answer for this one. Answer will be 10 because p direct to 1 and what are the value of the pointer value? Move pointer to 2. So we get the pointer value 2. Next 16 question, dangling pointer. So integer what are the pointer value we are giving? Next x value is 5 we are giving, pointer value again x. So what will be the value we are getting from that? 4 options are given, 5, whether it will be 5 or it will be going to the garbage value, or we are getting a compiler or runtime error, whether it will be in the loop or we are getting the runtime error, always will be getting. So let us see the answer for this. Garbage, undefined behavior, because the behavior is undefined according to the explanation given in the program. So we won't be getting any output for this. It will be, even though the pointer is showing the some value, it won't be effectively getting that. So x goes out of scope. Whatever the value represented by x goes out of scope. So that is called as dangling pointer. So thank you. We'll see in the next video.